Alright, so should be live now, so I suppose I'll just get started. So from the stream last night I managed to implement the reverse select display on here, so I can change drive profiles and I can also select gear. And if I quickly zoom over to my other view, you can see that that's also reflected on this cluster as well. I can toggle through that. So, I was thinking today, I've got about an hour to kill, so I'm going to be on the stream for about an hour. Let's see if I can fix the speedometer, so I can actually see if I can simulate some form of gearbox. Like, it's not going to be accurate, but I'm basically just going to take the engine RPM and multiply it by gears. I'm not simulating the torque converter or anything just yet, because that's going to get really interesting. And also I'm going to simulate it as if the engine's got infinite torque, because currently I can't be bothered to actually simulate that type of stuff. So let's get started. Excuse me. So first of all, so DV, yeah, so BS200 displays front wheel RPM, DH is rear wheel RPM. Now, I believe from some of the documentation I have, front wheels is used by the instrument cluster to display the speed of your car, but then the rear wheel RPM is used by the engine to calculate internally how fast the car is going. Like, they don't use the same set of sensors, which is an interesting find, but it's also a bit weird. But, well, it is what it is. So let's set these all to 0 so we say that the car is stationary on startup. And if I do that, the needle should be at 0. Yes, that's correct. Cool, and we say 0 kilometers an hour. Great. So I'm going to create a new... How am I going to do this? I'm thinking. Okay, let's do extern long wheel RPM. So I'm gonna say, output shaft RPM. So this is gonna be pre-differential. So the nag simulator I have on here will set this value here, but this value will go into simulate tick to set the actual wheel RPM. That's how I'm going to do that right now. So very simply. Also, by the way, chat, can you guys hear the music okay? Don't know if we have any issues this time. To wheel RPM. Oop, I'm going to cancel that. What are you complaining about? Int from short. Oh, yeah, okay, right, these are actually short, my bad. Yeah, dual casting. I hate C++ the way it's so strict in terms of actually casting stuff. Right, so now I need to go to nag and begin working out how to set. So I'm considering here, I want a common interface for my simulated nags, for my simulated transmission, and also the physical real one when I get to coding that. So I'm just going to create a new C++ class and call it nag iFace. And this is going to be a virtual class, so it can be extracted. What are we going to have in here? Oh yeah, of course you can't do that. Public virtual int get n1 RPM, because I know that. Virtual int get n3 RPM. So these are basically set getter methods for retrieving the sensor values from the transmission. Then virtual int whatever, we need temperature. Get oil temp equals 0. And then I also need on here a couple more functions. Virtual void set TCC. Oh, right. That. PD1 level. I need 2 for the other. TCC, MPC, SPC. Modulating pressure. Shift pressure. Torque converter pressure, and then we do the same for the shift valves. So 1 to 2 / 4 to 5 shift, 2 to 3, 3 to 4. Yeah, unfortunately, by the way, this is going to be quite a lot of just like coding this time. This is going to be a lot of simulation to write before actually getting to do anything. Let's think. That should be technically it that I need in terms of the interface to the actual transmission itself. So these are all the things that I believe transmission actually has access to. Oh, okay, and I'm going to need to do another one. Virtual int get the bat v. So this should just return the battery voltage in millivolts, and that is useful just so I know, or the transmission knows, exactly how much power is actually being sent to the solenoids in terms of voltage. Also useful in case we get a voltage drop. I suppose it's useful that we could measure that. N1 RPM is, let me get my documentation up on the 722.6 gearbox. One sec. Wait for this to load. Ooh, we have 6 viewers currently, great. N1, so if I search that up, blue. Oh, no, we don't. Speed sensors. Oh, it's N2 and N3. Whoops. Why? N2, N3. So it uses 2 speed sensors referred to N2 and N3. Both sensors are located in electrical conductor plate as shown in figure 19. Speed sensors, Hall effect sensors. Used to get okay, so N2 and N3 will report the same speeds in second, third, or fourth. So let's comment that. N2, 2, 3, 4. Which gears these are actually valid for? 4. If N2 and N3 input signals are not the same in all these gears, there's issues with the transmission, and the DTC for input speed sensor mismatch will be set. Actually, I'll zoom in on this so you can see. The N3 speed sensor is not reported in first and fifth gear. Okay. So this basically covers all of them. So N2 is all of them. N3 is not reported in first and fifth gear. N2 is not reported in the reverse gears. Okay. So R1 and R2 is N3. Input speed sensor overlap is a rationale check. It is intended to indicate a major transmission failure and will cause a loss of drive transmission going into neutral. Okay. Yeah, I've seen these when I took apart my own transmission, so it's interesting that N3 and N2 actually look physically different. I'll see if I can actually bring up a photo of when I did that. 1 second. here. So this is what I found interesting when I did this, is the fact that they're both Hall effect sensors, but N3, I believe, no, N2 is this one here with the metal surface on it, and N3 is this one here with the plastic top. But they're both magnetic. But I don't know why they've put plastic on this one and not on this one. Just a strange quirk I found within the valve body of my own gearbox, but a bit of fun. Right, back to this. Actually, voltage. So for my NAG52 simulator, let me actually create a virtual version of that. So up here, include nag iface.h. Class virtual nag iface extends public Wait, is this how you declare classes? Oh, hey Alex. Nice to see you here. Public NAG52 iface. Now, here's what I'm curious about. Can I... Oh, there's no easy way. That's a shame. There's no easy way for me to implement these functions in CLion. So let's just do that. Take away virtual from all of these. Yep, okay. Yep. Okay, I'm just thinking here. So let's actually set a virtual transmission interface here. So, oh, of course, I need this before that class, or else it won't work. So private. Hey, why won't you detect that as a class, CLion? Okay, I'm just putting that in iface. Let's do that and see if that compiles. No. Error redefinition of short. Oh, yeah, okay. Whoops. Short output shaft RPM. Okay. And in this header file. Hey. Oh, it's in ABS, I remember. So short that external short output shaft RPM is equal to 0. Why is it redefinition of short int output shaft, but the definition just says short? Oh, could it be this? No. Why? Previous declared here. Oh, yeah, okay. I can't redeclare that, I just have to set that, I think. I'm hoping that fixes it. C++ requires type. So I'm putting type here, and it's saying that it's a redefinition. Redefinition of short, but why is it saying short int? This is just a short. Oh, right. I need to actually, like, uncomment. That's probably why. There we go. Nope. Oh boy. Linker errors. I love these. Undefined reference to vtable for nag iface. Okay, you don't even need a C++ class. Undefined reference to vtable. and that's coming from here. Genuinely confused as to why I'm getting this. Okay, so undefined reference v table. Let me have a look. Let me look that up. Could it be because I need to have a constructor? Oh no, you can't have a virtual constructor, can you? Like that? No, that shouldn't matter. You ask, since they're virtual functions, do they require the override on the extending class? I can't remember. It's been a while since I've done classes in C++. One sec. Oh, it might actually be because I have to implement them. One sec, let's just quickly do that. Oh boy, now I got more errors. Great. Undefined reference. Okay, so let's have a look at this header file again. Oh. You're saying like this. Well, it's not screaming at me, so I suppose that means it's okay. Ooh. Oh, nope, same errors. That did absolutely nothing. You definitely mean like this, Alex, don't you? This is mildly frustrating. I did not plan to spend half my time this evening sorting out a class issue. Can you go to the CPP file? Yeah, sure. CPP file is here with all of the functions. Well, the functions that you care about are down here. Wait, what? Why is it doing this? Why did CLion decide to create the function like that? It should do nothing because that function's virtual. Okay, we now have less errors, that's good. It's just the same one now, back to undefined reference to vtable. Oh, you know what? I might have just realised this. My mistake here. I may have just realised that. You should all be virtual. There we go, it now works. So it's just us forgetting a couple of equal zeros at the end. Okay, right, great. So for this I want to return 12, actually we're saying the engine is running, so it'd be 14,300 for 14.3 volts. That's what I get on my car at least when I'd actually run it. For that I'll return 80, just say that the gearbox is warmed. So if I now, where's I'm setting T oil, here we go, so this I face get oil temp plus 40, oop, is a private member. Oh yeah, my bad. It should all be public. There we go. So it should still report gear. Yeah, okay, that's good. Hasn't broken it yet. Right. I'm thinking here. 1 minute. Cancel this. So I'm going to create a in my nag face here, I'm going to actually start to set gear. So union class, union V gear, and we're going to say, so 722.6 has got park, reverse 1, reverse 2, neutral, drive 1, drive 2, drive 3, drive 4, drive 5. Okay. So now, based on, I mean, I'm also going to create a variable in here saying private. This will be a private value actually. We should do that. Private void. No, it'll be vgear get gear. So this is just one sec, I'm thinking. No, we don't actually need that. We just need vgear virtual gear, which is currently what the transmission is supposed to, in quotation marks, be in, or my virtual gearbox. In reality, this will just be used to basically set the N2 and N3 speed sensors when the simulation requests it. I'm going to say by default that's park. Actually, let's just move these out. Okay, you still build. Good. So I'm trying to think. N2 and N3 RPM is the output shaft speed, not the input shaft speed. So I'm going to say here. Where is it? Where is get this? Okay. So int engine RPM equals ms 308.getNmot. So that's basically the engine RPM currently, and we're going to say int output RPM is equal to engine RPM times. Ooh, wait a minute. Hold that thought. So output shaft speed in neutral. Okay, got it. Right. So int divisor is equal, or divide. gear ratio is equal to I'm used to writing Rust, switch this this virtual gear, and then we're going to say case v park. Oh yeah, of course we can't actually do that. Switch that case v gear park. So in park or neutral, this should be 0. Okay. Case v gear. So let me think. N2 RPM. N2 is the one which doesn't report in reverse. Okay, so N2 is everything but reverse gears. Okay. So in that case it would be case v gear R reverse 1, case v gear reverse 2. And then in drive 1 I'm going to say int output RPM. Let's just do that. So output RPM. Actually, you know what? Let's clean this up a bit. So let's just do, and also default is just to break. Output RPM is equal to what did I call these values? I had them in a header file here. D1 rat, in case it's rat. D1 rat times engine RPM. Wait a minute, it'll be engine RPM divided by that. No, wait, let me check. Okay, so overdrive, so it would be D1 ratio times engine RPM. Break, case v gear D2, case v gear D3, case v gear D4, case virtual gear D5. Just going to break under all these for now and I'll just set the ratios manually. Cool. I'm trying to think. Oh no, it would be engine RPM divided by the gear ratio. Because when you go to overdrive, the engine RPM is spinning less. Yeah, so it would be like this. No, would it be the other way around? Hang on, I'm just going to do it like this for now, and maybe I'm just having a bit of a brain fart. 1 minute. And then we return the actual output RPM of that. Then we have to do the same for get N2 RPM or N3. So in this case it was who reports when. So N3 is 2, 3, 4, R1 and R2. Okay. So D1 goes down to here where it's 0. Reverse 1 and reverse 2 come out of here, and we put them in their own little block. Yep, this can disappear now because it's no longer being reported. 2, 3, 4. 2, 3. Oh yeah, and gear 5 also doesn't report in this mode. D1, D5. By the way guys, how's the music? Just let me know. I've got some lo-fi stuff on currently. So that'd be R1 ratio and reverse 2 would be R2 ratio. Okay. So for my virtual interface, I'm also going to create a separate method which will be on here. Oh no, wrong header file. Which will basically force it to go into a park reverse neutral position, because that's normally handled physically rather than through solenoids. There's like a mechanical linkage changes those gears. So void set EWM position WHC pos. Okay. And we can implement that, generate definition. So this if pos equals park, oh no, WHC GSP, else if pos equals GSN, which is neutral, else if pos equals GSP, actually I'm going to PRN, and then else if pos equals GSD. So these are the only conditions of which we can actually set the position of the valves manually. This V virtual gear equals V gear park. You are simulating the W5A330. Yes, that is what I have. However, I have the actual. I can just basically uncomment this and change this to W580 and then get those gear ratios out. So if I want to, I can simulate the bigger gearbox, which is for, you know, more torque. And also have very slightly different gear ratios. Because ideally, what I want this to be is for it to be a plug-and-play system, so you can just basically slap out your old... Yeah, so as I was saying, sorry, I just got sidetracked for a sec. So I'm intending this to just be like a plug-and-play system where you can just basically go, yep, slap out my old EGS controller, put in my own one, and off you go. That's what I'm hoping for. No need to SCN code or anything, because I think I have found a way on my own car to measure the wheel diameter rather than setting it in SCN coding. So I'm thinking, because this gearbox controller requires a training session where you basically drive the car for 5 minutes, just for it to get a feel of the actual car, then it can kind of calculate in memory, well, it can calculate and store it on flash, your actual wheel diameter. So set 3 to 4. So if this virtual gear is equal to virtual gear D3, else if this virtual gear is equal to virtual gear D4. So if it's in virtual gear D4, we want to downshift to virtual gear D3. And then if we're in drive 3, we want to go to drive 4. And basically we want to do this again, so 2 to 3. So gear 2 or gear 3. So if we're in 2, we want to go to 3. If we're in 3, we want to go to 2. 1 to 2 is a bit different, because 1 to 2 actually controls 1 to 2 and 4 to 5, so we need to do 2 sets of this. Drive 1, then we go to drive 2. If we're in drive 2, we want to go to drive 1. Does it really know wheel diameter? Well, you can calculate that. I've done it in my own car, where you can actually calculate the wheel diameter based on the current speed reported by the instrument cluster, because the instrument cluster actually reports the current speed of the car, and you also know the individual RPM of the wheel, of each wheel, so you can get a very good average over a 5-minute period of driving. So if we're in 5, we want to go to 4. If we're in 4, we want to go to 5. Yes, but stock nag does it. I believe with stock nag it's an SC encoding variable, so you can change it. But I'm not. But if it is for that diameter, because it's the diameter of something it has on it, which is very close to the wheel diameter of my actual car. However, I'm not entirely sure what that value is for, because I thought because nag doesn't actually calculate the wheel speed, like it has no need to, because ABS does that, so I don't know why it would do that. I wonder if it's for torque calculation, come to think of it. Because I know nag somehow calculates the amount of torque the engine's producing to then work out whether it should up or downshift, or just hold the current gear. Let me tie this on here. So this TCC. Ignore this and ignore this. On the W205 I found that it shows negative torque. Oh dear. That's very strange. You see, thing is, right, I don't quite know what that torque reading represents. Like, I don't know if it's just a looping value. When you don't press on the gas pedal, it does kind of engine brake. See, I wonder if the torque values actually increases over time and it uses that delta, so it's a wrapping around value rather than it actually giving you a static number saying this is the amount of torque I'm currently producing. I wonder, I don't know. Mercedes cars are really strange, but you know, they somehow work. WHC has not been declared, oh no. That means I just need to do that should fix that. Don't understand how it works. Is it just a calculation from some constant value or using sensors to measure it? You could theoretically use sensors to measure it, but then nag has to know the wheel diameter, it also has to know the current weight of the car to calculate how much torque it's being produced to move the car with acceleration, which I suppose is too much, so it must use some kind of static value somewhere as an estimate. Because, for instance, if you add, obviously, if you, for instance, add some fuel to your car will be heavier, so therefore it will accelerate slower. I mean, I know the engine current has a very useful output for torque numbers, which is a constant value, so like it will fluctuate based on how far you have your foot down, but it will never wrap around like you're explaining. And there's two values, there's one for torque without turbocharger and one for torque with turbocharger, so I don't quite know how they differ. I mean, they differ in values, but I don't know how it's calculating either of them. Mystery. I'm just going to change this to an integer, just to avoid this linker error. So we're just going to say if pos equals, so 0 is park. One, 2, 3. Cool, that works as expected. So, Let's see if I can now set the output shaft RPM correctly. So every simulation tick, where is that? Where are my simulation ticks? So this. So GSP would also mean this set. Oh, iFace. Set ET from position 0, because we're in park now. All this we're in. Reverse neutral drive. 4, 3. No, that would be 1, 2, 3, I think. That's how I had it. Where 3 was drive? Yeah, 3 was drive. If this virtual gear is equal to... Hang on a minute, so I need now to check... So I don't want... this is frustrating, 1 sec. Equals to park. So I'm basically making sure that it can't suddenly go into gear 1 if it's in any other forward gear. So we only ever put it into gear 1 under that circumstance. Okay, so still nothing suitably. So which one starts us off in first gear? In first gear we have access to N2. So basically for my testing purposes we just need N2. So output shaft RPM equals to this iFace get N2 RPM. Let's try that. Okay, so currently in park, that's good. It's not doing anything. If I now put you in, let's see, go forward. Oh boy, that's not worked at all. Currently doing 495 kilometers an hour. Oh boy. At idle RPM. Let's just speed that up a bit, shall we? Oh boy. Okay. Time to rethink this. So, I think the actual formula is the engine RPM divided by the gear ratio. And not multiplied. Okay, let's try that now. I mean, you can now apparently do 120 miles an hour at 4,500 RPM now. I see that as an absolute win. In first gear, shall I say, as well. And you can see the cluster on the bottom there is also doing stuff correctly. So I reckon there's also other multiplication as well going on. So if I go to ABS... So I know at my car, if I'm doing 2,000 RPM in 5th gear, that equates to 60 miles an hour. I know that. And no, sorry, in 4th gear, 60. So these two would be perfectly synced. Oh, probably because I need to do output shaft RPM divided by 2.8, not times. Okay, that seems about right, because I know when I'm driving my car, like, red line in first gear is about 15 miles an hour. So that seems very correct. Okay. So, let's now tell it to upshift. So going back up here, down, right? So switch this current forward gear. So if we were in case 1, case 2, case 3, case 4, case 5. So case 5 and above should just break. And also the default statements as well. So case 1, so downshift. Oh no, wait, for downshift we should break. Oh shoot, I've done that wrong. So we should go 5, 4, 3, 2, 1. So 5, this, high face, set 1 to 2, and we'll say set to full blast there. This, interface, 4th gear. Wait. Yeah, true. There you are, Ash. Set 3 to 4, 255 pressure. I should also then set this gear. This forward, current forward gear is equal to 4. And this forward gear is equal to 3. 3, 2. So if we're in, this goes to second, this goes to first. This is also using the 1-2 shift, and this is also set 2 to 3 shift. And then we just have to do the opposite for the upshift logic. It's going to be so simple. This is going to be state-of-the-art transmission shifting right here. So if we're in first gear, second gear, third gear, oh, didn't need to change that, fourth gear or fifth gear we do nothing because we can't shift up. Set 1 to 2, 1 to 2. So basically, you just have to swap this round. Set 2 to 3 and set 3 to 4. 2, 5, 5, and obviously change the gear to the next one. 5, 3, and 2. Okay, so this is never actually used, so I can get rid of it completely. Bye bye. Yep, that can bye bye. So let's just do a quick thing here, saying if this nmod do this. Oh no, it's ms308. ms308 dot nmode is greater than 3000 RPM, then we should upshift. Whoa, look at that. Oh, and also check if we're in drive. We should also probably do that. And EWM230 dot get wishes equal to drive. Okay, let's give this a go now. So if I first of all put the car in drive, right, and then at 3000 RPM it should go snap into next gear. Let's try that. So accelerate. That did nothing. Why is that? Why did the upshift logic not work? Okay, how about we just do a little print statement here to say that we're upshifting. Oh, of course, because I haven't actually set the current gear. That would explain it. So let's say this current forward gear is equal to 1 if we just set that. Now let's try. So we go to drive, and let's begin to accelerate. Oh, okay, that's... Oh yeah, of course. So we're accelerating the car, Oops. Okay, this is also very wrong, because apparently in 5th gear now, at red line is 70 miles an hour. Let's put our downshift threshold is less than... Let me think, less than what? Let's set our downshift value at 1500 RPM. Oh, yeah, greater than 3000 RPM because we're looking upwards, and smaller than 1500 RPM. Then we should downshift. Okay, and then let's have a print statement here saying printf upshift to this current forward gear, and we'll do the same for downshift. So let's have a look. So put it in drive. Okay, let's accelerate. Oh boy. Yep, you're doing it again. And it's not downshifting. However, that might be because I think I forgot something. Did I? Yes, I did. I forgot to say this last RPM is equal to current RPM. Alex, it is upshifting, but it's just not changing the engine RPM, so basically all that ends up happening is the speed of the car exponentially increases. See look how slowly the car is currently accelerating, and as soon as I go past 3000 RPM, watch this, whoosh. Yes, I know, I need to now basically make it physically affect the engine RPM. Current RPM. So I'm going to create a motor... No. What am I going to do here? Is there a way I can access the simulation? No, I can't. Damn it. Okay, this is the problem. I need to create a feed loop so the transmission can then affect the engine RPM. The engine RPM can affect the transmission RPM as that accelerates. carsim.cpp, put that up here. Extern car simulator sim is equal to null pointer to begin with, and we're going to put in the constructor that is equal to this. So here we're going to put sim equals this, and then in the destructor, will you be updating your Mercedes hacking guide? At some point, yes. I need to go ahead and update that, but as you can probably tell, I'm working on a lot currently, so just a bit busy, but yes, I do plan to, especially once I get some of my own tools out, which might help you guys with Mercedes hacking. I do then plan to ship that. Okay, so as I was doing, in my engine I now need to set a void force, make this public. Void force set RPM short RPM. And we're going to say this current RPM is equal to float RPM, and this delta RPM is equal to 0. So it basically has to re-accelerate. Okay, so if I go to nag, where's nag? Here. And we say after an upshift that we have to now forcefully set the engine RPM. This fine, I'll just include canvas carsim.h. This might create a cyclic dependency, let's have a look. No, it builds. Brilliant. Okay. So, if we do now sim where's sim get engine set RPM 700. I'm curious to see if this will now actually upshift. Oh no, wait, if we're downshifting we want to set you to 2000 just as a test, and no problem. Happy to keep the dock. Well, happy that we've got the dock so far. And if we're upshifting, we want to set you to 2000. So let's just see if that works now. So they should both set the engine RPM to 2000. Reverse nuclear. So it would just keep setting it to false. Okay, let's do that. Let's correct that. Okay, now let's see. So let's have a look. See, accelerate, go. Okay, that actually works really well. And then now it should start downshifting. Woo, look at that. Okay, I can get rid of these print statements now. I know it works. So that's why I never use switches as a case statement. Yeah, I know, but I'm used to doing it because in Rust it's actually really pretty to do. You just have little arrows, but yeah, C++ and C, yeah, not great. Actually, you know what we're going to do? We're going to do something really cool here. We're going to actually change the upshift and downshift, just like Mercedes have done. We're going to change the upshift and downshift thresholds based on the current profile of the car. So let's do... Also, there's definitely something wrong with the ratio, the wheel RPM. So if I just get rid of this entirely and do ×3, let's see what happens. Yeah, that's clearly not correct. Okay. So if I just tell output shaft RPM and assume a 1-to-1, what happens? Second, third, fourth, fifth. Okay, so it's not 3 because that's too much. I'm gonna go for 2.5. Okay, so at a ratio of 2.5, we now have a maximum limit on the car of 8,000 RPM. Of 80 miles an hour. I can check if your car, if you want. Yeah, sure, Alex. You know my VIN number. I'll give it to you quickly. Not in here. Let's see if I can quickly forward that to you. Right, that should be my VIN number. Also, I need to fix this at some point. The engine RPM is a bit bouncy. Yeah, as you do. Oh, also, let's actually go and set the engine RPM correctly now. Because I'm currently just setting it to a placeholder value of 2000 RPM. So this would be... So I need to create another one saying int get force engine RPM So this function assumes shift had just completed. Engine RPM must be set. So int. So we basically just have to do reverse now. Int output. So we have to take the output shaft RPM and divide it by the current gear. Okay. Output shaft RPM. So return switch this forward. Switch this forward, current forward gear. 2.87, thanks. I'll go add that in a sec. Case 1. So this is now the new gear, so output shaft RPM times that by D1 ratio. Return that. So case 1, case 2, 3, 4, 5. Three, 4, 5. Case 2, 3, 4, 5. Oh, I don't care about that. Okay, so force engine RPM, this force engine RPM. So this should get the current engine RPM we need to force it to. Oop. And you said it's 2.87, so let's quickly do that. Divide by 2.87. Okay, so now if we accelerate, okay, that seems about right. The gear ratio, so we're setting it correctly now. Thing is, it's just doing it a bit too quickly. Okay, what I'm going to do is I'm going to check if we're in drive, and if we're in drive, I'll limit the maximum acceleration and deceleration of the engine. That seems to be a nice way of doing it. So, if EWM230.get WHC is equal to WHC drive. So if we're in drive, we're expecting some drag from the powertrain. So this delta RPM, we'll say divided by 3. Neutral, drive, go. But again, see, we seem to be still hitting this limit, whereby we seem to... yeah, 20 horsepower engine, mate. We seem to be capped at 70 miles an hour with this setup. I can't seem to get past 70 miles an hour. Which, to be honest, is quite funny, but... Oh yeah, look at this. See, Alex? Infinite deceleration right here. You could coast for 30 miles on this engine based on how slow it's decelerating. Oh man, this is beautiful, just watching this. Okay, we'll just divide it by 1.5. We'll make it slightly less. Okay, one sec. I'm going to also add another thing here to simulate this. Where is it? Where is it? Where is it? Pedal percentage. There. Let's see how this accelerates now. I'll actually put up a virtual cluster so we can see how this would look if you're actually noticing it. Ignore the display malfunction, that's normal. If you accelerate. And again, we seem to get capped here at 70 miles an hour, which is a bit pathetic. I can't even hit highway speeds with this. Well, actually, I want to see, can I very quickly dunk it in neutral? Oh yeah, I can. That's a bit of a flaw. Hey, why? Oh, because it now thinks it's in gear 1. Okay, I see. I think it's after you've added brakes. Yeah, I know. So I'm just gonna... So that's the differential value. Is there another internal, like, value I'm missing from the transmission? I'm thinking. I'm gonna hazard a guess. Let me see if I can times it by my wheel my wheel diameter. I believe I had that written down somewhere. Where is it? It's in Virtual Combi. Yeah. 2.23694. I think, no, RPM times gear times diff times wheel diameter. Yeah, so we currently have meters per second. This is how it's calculating speed, by the way. Meters per second, and I know this is correct because the physical cluster also agrees with this. Meters per second equals wheel circumference times average RPM divided by 60, or revolutions per second. Yeah, so wheel circumference meters in this case is 2.000. So if we just times it by that, then what happens? Where are we? We need to go to NAG, or ESP. Yeah, I know you can only see IC, but yeah, I just wanted to quickly just add that, but I was just quickly thinking about something. Neutral, reverse, drive. Let's have a look now. So if we accelerate in first gear, that takes us to about 20 miles an hour. Shift to second. Third. Fourth. Fifth. And how fast can I go in this? That seems more akin to what this engine's capable of. I think that calculation is now finally correct. So let's slow down. Cool. So I think of wrapping this up, by the way, in about 8 or so minutes at past. I mean, we've kind of finished what I need to do today. So... okay, let's make the car accelerate insanely quickly. Only during acceleration we want that to be done. Okay. I think that works. It's good enough for now. Like, obviously over time I will improve the simulation accuracy and also begin working out how much torque the engine's producing. I can probably gather that from CAN bus log files that I've created over the years for my car. and just have a look at how much the engine produces based on fuel, because I think you can calculate the force of each explosion in the cylinder. Physics. To then roughly approximate exactly how much torque the engine is producing based on how much fuel is being injected into it, which I know because I have the map for my engine. Well, I've built it from data that I've been collecting over CAD based on how far I have my foot on the pedal and also how much fuel it's injecting. I also need to make it so that there's more drag at higher gears, because in first gear you should have way less drag on the engine RPM increasing than you would in, say, second or third gear, or fifth gear for that matter. So if I say force engine RPM with the current gear that we're in, then that could be a multiplier that we divide by. Maybe. Short RPM. Case 1, case 2, case 3, case 4, case 5. Return D1 ratio, return D2 ratio, return D3 ratio, return D4, and return D5 ratio. And let's make the default just 1. Okay. This get gear ratio. So let's see what funkiness this does. Why did it do that? Oh boy. That's gone horribly wrong. Well, we're slowly slowing down apparently. Oh, there we go. Oh, I think it's because I'm setting it every single tick. Whoops. So what's the multipliers normally on this? Okay, so if I say... If I do the additions and multiplications based on that, then it might be a bit more accurate rather than just setting it every single tick. Actually, Alex, you know what? I think you're right. I think it's multiply. No, that's not going to work, because... Okay, if we say divide that by 10, so we do drag over 10, let's see what that does. Because I'm worried at lower gears it's going to just be insane values. It's accelerating first, second, third, fourth, fifth, and then coming down. Oh, yep, it's gone wrong. Fourth, third, second, first. Something is wrong here. Yes, I know, Alex, something is wrong, but I'm trying to work out what it is. Just get rid of these drag coefficients. Alright, so I think I'm probably going to call it a night, and I'll update this all now on GitHub. Just do that, and we'll push that. Alright, so thanks everyone for watching. Regards to availability, probably Friday or Saturday next week will be my next stream. So see you everyone until then. Thanks, goodbye.